Hi, I thought I would do a little R video, R script video of the assignment 2 on the Drumnet export promotion scheme and just walk a little bit through the code so that everybody sees how the code should have looked like if you had done it correctly, which most people did. So here's the script, and as usual, we have our header. Very clearly marked with maybe some other data about what this where this script came from. We clear out the working space. We set the working directory, which you would need to do with your working directory in order to read in the Drumnet data set, which you got off of Camino. We have a set of packages that we're going to use: tidyverse, the do-by package for summary tables, crosstabs. Which you can do them in the tidyverse and Dippler also, and you might want to start exploring how to do that. And maybe I'll do it a little bit later. And then our usual commands. We go down and we read in the Drumnet data set. So we'll just do that. And you're all reading in. And I didn't read the, did I have that on with a hashtag? No. Oh, I don't have the, yeah, I have a hashtag for setting the working directory. So let me run that, see if that works, and read the file in. And there's our Drumnet file, 1,832 observations. You remember that we have the age, we have a bunch of explanatory variables, we have an ID for the for which village the person is in. The village has a soil quality, so that soil quality is the same for every village. And we have whether they're male or female. We have whether they're in the treatment group or the control group. If they're in the treatment group, we have whether they're in group 1, group 2, or group 3. And we have whether it's pre or post, whether we're observing it. And then we have the 2 outcome variables, the percent of crops exported and the log of household income. So those are our main variables. And we can go back and do our analysis. First thing we do, as usual, is a table of descriptive statistics. And we don't want to mix up the pre and post period. So we'll do a table just for the pre-period where post is equal to 0. So I actually don't need this Drumnet $. Take that out now, rerun it again, because we've already told it that it's the Drumnet data set. So there's our table of descriptive statistics. We get the, as usual, right, the mean, standard deviation. We see that the data is complete for everyone, and not much else to say there. Then we have we might often want to look at summary statistics, the mean of the outcomes. So here's the mean of household income by treatment status, just looking at the pre-period and calculating the mean. So we see that household income for treatment 1, treatment 2, treatment 3 is roughly the same. When we go to the post period and look at the means, we see that treatment group 3's mean household income is twice as high. The log of mean household income is twice as high as treatment group 1. We can do that for the export percent. So the exports are roughly equal before, 5, 5, and 4.9, but afterwards they double, right, from 8.69 to 18.89. So quick way to see the differences in the means. It doesn't tell us the statistical significance of those differences, but usually with a sample size this big and pretty large differences in means are going to be statistically significantly different. I also asked you in the problem to do a box plot. To do the box plot, we're going to turn the treatment variable into a factor variable. So if we look over here at the treatment variable, we see that it's not a factor variable. It's an integer, 1, 2, 3, 1, 2, and 3. So we turn it into a factor variable. And the reason is we want the box plot to display on the x-axis the 3 treatment groups, and on the y-axis the distribution, the mean, the 25th percentile, the 75th percentile, the outliers of that value. And we see that for treatment group 3, pretty much all of the observations are higher than the mean for treatment group 1. That's for the income side. Oh, that was the export side, sorry. Here's the income side, and this is group 1. So yeah, I'm sorry, I jumped a step there. So you can see that how it works. So that's nice. And then we have the regressions. These are our standard impact evaluation regressions. So we have a linear model, regular ordinary least squares regression. The log of household income is the outcome variable. The dummies for the treatment are there. The dummy for the post period is there. And then we have treatment interacted with whether you're being observed in the post period there. So our first one doesn't include any control variables, and our other 2 regressions include a whole bunch of control variables and interactions of control variables. And then in our 4th regression, we say, well, in addition to the control variables, why don't we have a dummy variable for every, I think DID was every household, so we can have a control variable for every household. Maybe it was every village. Right, it's the self-help group. I have it right here in front of me. It's the dummy variable for the 40 or so self-help group. So we can imagine that each self-help group is in a different geographic location. And so the income response to the export promotion program might differ according to where they are. And so we have many observations per self-help group. Each self-help group might have 10, 20, 30 farmers in it. So by having a dummy variable for every self-help group, we control for a lot of the variation between people, which is just due to them being in different regions rather than being due to the program. So those are our 4 regressions. We run the regressions and display them with our usual Stargazer table. And remember, our coefficient of interest, I'll make this a little bigger. Our coefficient of interest is the dummy variable for whether you're in the treatment interacted with whether we're observing you after, and we see that that's about 0.56 for true, and it's about 0.99 for, it's 0.56 for treatment 2 and 0.99 for treatment 3. So treatment 3 gets about double the impact of the program as treatment group 2 is. That's pretty much all we need to observe. Now, do look at how the R squared goes up as we include control variables, right? So it goes up from 0.71 up to 0.92. And then when we have the dummy variables for the villages, which we don't display, we use the omit command, right? So here's the Stargazer with omit all those coefficients. If we didn't have that in there, we'd have 40 coefficients for each one of the dummy groups, but we're not interested in those coefficients. Notice also that the standard error changes as we add more. The coefficient itself doesn't change because in this particular case, the regression, since kind of made up the data itself, the impact of the treatment's not correlated with any of the other explanatory variables except for the treatment, because I made up the data that way. Normally, it wouldn't be quite so clean as this. But notice that the standard errors do change as we increase the explanatory power of the regression by including more control variables. And lastly, do a little graph of exports and income, and I just wanted to show you the power of R of color coding the scatter plot with the treatment group and having a different regression line for each treatment group. So you see very nicely that group 1, which is the red dots, that there are a fair amount of increase in exports, but not so much not so big of an income in that post period. Remember, this graph is for the post period. Treatment group 2 a little higher, treatment group 3 even higher than that. So I will stop there, and feel free to send me any questions that you might have.